हेलो वेलकम टू मैथ्स ड्राइविंग सेंटर। आज हम लोग एक बहुत पुराना क्वेश्चन मैंने शेयर किया था वो डिस्कस करेंगे, जो कि दिसंबर 23 का क्वेश्चन है, ग्रुप थ्योरी का। क्वेश्चन समझने के लिए इजी है, विच इज वेरी इजी टू अंडरस्टैंड, बट टू सॉल्व इट इज नॉट दैट इजी। ओके, इट इज अ पार्ट सी क्वेश्चन। मैंने भी ट्राई किया था इस क्वेश्चन को। पहले तो मेरे दिमाग में जो आया, जो आपके दिमाग में भी आया होगा, कि क्वेश्चन समझने के लिए बहुत इजी है। कि वी आर गिवन ए ग्रुप, we have to find that order which is denoted by A, and now we have to check that A is divisible by what. So we know this group, this is called general linear group. Okay, G, L, N, Z, P, we denote it by like this. Here we know the formula of finding the order, which is if we apply here, it will be 9 square minus 1 by 9 square minus 9. So I thought it is very easy. How can someone give this very easy question in part C, which is 4.75 marks? And time is also not consuming. The CSI will net will do like this. If the question is easy, it will be time consuming. If the question is means something is there, then it will be easy, means it will be very easy, means directly it will be solved, means but you have to think. But here nothing to think. Here we just apply the formula and then we will find the order. How can it be so easy? So I just skip this question because this is a wrong method. This formula does not apply here, because the formula that we know, it is like this: GL and ZP, where P is prime. We have to here 9 is not prime, na. 9 is not prime, so we cannot apply this formula here. So for that, when we have P prime, means the field is prime, then the formula is P to the n minus 1, P to the n minus P. Okay, so we cannot apply this formula here. So how to do this question? So you just have to think something out of the box, means not very direct. So now how to think? Let me just start. Okay, we know the formula of what you know. You just write it down. We know the formula of GL to Z3, right? Because here 3 is prime. Okay. Now you think, can you define some relation or function between these two? You have to think like this. Obviously, all the elements of Z3 also lie in Z9. Okay, this is a subset only. So, all the matrices GL to Z3, two cross 2 matrices, will also lie in this GL to Z9. Okay, that I think it is clear. All the matrices of GL to Z3 will also lie in GL to Z9, because all the elements of Z3 are also the elements of Z9. Okay, now how to define something, some relation? Okay, whenever we are given some question of groups, you think of homomorphism. Can I define a homomorphism? Because with the homomorphism we can get some idea. So obviously you will define a homomorphism from bigger group to smaller group, because it is easy to define like this. Okay, so we will define a homomorphism. Here I have written from GL to Z9 to GL to Z3. See, we took two groups. This is G, you say this is G dash. We know this order. We know the order of this group, but we do not know the order of this group. Now you just define a homomorphism. How can you define? You take any element means what? You take any 2 cross 2 matrix from this first group, then the elements are from Z9. So we have to go to GL to Z3. So you just take mod. It is not very difficult to think like this. You just take any 2 cross 2 matrices where elements are from Z9. We have to go to 2 cross 2 matrices where elements are from Z3. It is like this. Let's see, f of A, B, C, D. If we take any 2 cross 2 matrices, A, B, C, D are from Z9. You take mod 3 of all the matrices, of all the elements. A mod 3, B mod 3, C mod 3, D mod 3. So that will be a homomorphism. You can just check. This will be a homomorphism. By applying definition, you can check, right? So how it is? Like, for example, I am giving, if we have 8, 1, 2, 3, this is the element of GL to Z9. So its image will be, you take mod 3. So 3 to the 6, remainder is 2. Here it will be 1. Here it will be 2. Here it will be 0. So this is the image of that. Now again f of 7, 2, 3, 8. What will be the image of this element? So you take mod 3. It will be 1. It will be 2. It will be 0. It will be 2. Okay. You got it. So now I will say that this is not just a homomorphism. This is also a onto homomorphism. Okay. Now how can I say that? You just think, as I have said earlier, that all the elements of Z3 are also the elements of Z9. This to you know na. 0, 1, 2 are the elements of Z3. In Z9 we have 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now all the elements of GL to Z3 also lie in GL to Z9. This also I think it is clear. So now for onto what we have to check, that if we take any matrix from the codomain, we will get a pre-image of that matrix, right? So for every matrix A belongs to GL to Z3, let us say for example you take any matrix, say for example I will write 0, 1, 2, 0. This is the matrix in of GL to Z3, right? There exists that same matrix A. You take this same matrix only and you map it here. See, it will give you the image. So what I am saying is that you take any element from the codomain, that same element will be the pre-image. It will be like identity function. See, like it will be f of a equal to a. So for every element in the codomain, we are getting a pre-image. So this is a ontomorphism. See, you just think, it is not very difficult. Okay. So it will be like identity operation function, means not identity homomorphism, but only for the elements in the codomain we will get that same matrix only. And also we will get some other matrices also. Okay, this you don't confuse it. We will get other matrices also, but what we need only for every element in the codomain we just need one pre-image. So I just told you that existence of that matrix, that same matrix will be the pre-image. Okay. So that is a homomorphism and onto there is a onto homomorphism, that the homomorphism that we have defined. Now why I am doing this? Because if I have defined a onto homomorphism f of g to g dash, now you think about the fundamental theorem of homomorphism. What it says, that g by kernel of f is isomorphic to g dash. So if the two groups are isomorphic, then order are also same. So order of g by kernel of f is equal to order of g dash. So it will be order of g equal to order of kernel of f into order of g dash. Up to here it is clear, I guess. Okay. Now we know the order of this group g dash, right? We have to find the order of kernel of f. Okay. So now how to find the number of elements in the kernel of f? You just think about a definition of kernel of f. What is the definition? All the elements in the domain, all the matrices in the domain which are mapped to the identity matrix in the codomain. I mean, identity element. What is the identity element in the codomain? The identity matrix only. So we have to think that what are the matrices in A which are being mapped to identity matrix. Means if I take any element A, B, C, D, here let me rub it down. If I take any element A, B, C, D, after taking mod 3, how can I get 1, 0, 0, 1? This we have to think. So how can you think? In Z9, how many elements are there? 0, 1, 2, 3, 4, 5, 6, 7, 8. Now you just take mod 3 of all these elements. See, after taking mod 3, it will be 0, 1, 2, again 0, 1, 2, 0, 1, 2. Right? This is clear. Now you think, how many elements are there that after taking mod 3 we are getting 1? See, 1, 4, 7, 3 elements are there. How many elements are there in Z9 that after taking mod 3 we are getting 0? 3 elements are there, 0, 3 and 6. So you just see that for small a we are getting 3 choices, that after taking mod 3 we are getting 1. Again for B we have 3 choices, again for C we have 3 choices, again for D we have 3 choices, right? That way you have to think. So order of kernel of f, it will be 3 to the power 4. Like for example, if I take element like say 4 3 3 4, its image will be 1 0 0 1. See, 4 after taking mod 3 it will be 1, 3 after taking mod 3 it will be 0. That way, how many traces are there you find out, and then you just multiply it. So order of kernel of f, it is 3 to the power 4, and then we are done with this question, because order of that domain, which is GL to Z9, after applying this theorem, see this theorem, order of G equal to order of kernel of f into order of G dash, and G dash it is GL to Z3. We know the order of this group, order of kernel 3 to the power 4, order of this group is 3 square minus 1 into 3 square minus 3. So you just simplify it and we will get this. This is the order which is denoted by A. Now you just check the options. We got 3 to the power 5 into 2 to the power 4. Now we are done with this question. So our answer, it will be A is divisible by 3 to the power 4. Yes, correct. A is divisible by 2 to the power 4. It is correct. A is not divisible. It is written. So it is false because it is divisible. A is divisible by 3 to the power 6. It is also wrong because we are getting order 3 to the power 5 into 2 to the power 4. Okay. So I hope you have understood this question. It is not very direct. If you have any doubt, you can reach out to me. And also, I just want to add one thing, that there is also a direct formula for this type of questions, but I don't know the formula. So if you know, then please send it to me. Okay, the number is given below in the description. Okay, I'll be grateful to you. And if you got any value from this video, if you like, please like, share and with your friends and subscribe to. मिलते हैं नए वीडियोस में नए क्वेश्चंस के साथ. तब तक चलते रहिए, चलाते रहिए खुद की गाड़ी को आराम से. मिलता